So the topic of this research was to build a robust model that would predict housing prices and then check whether visual features taken from satellite images could improve this model. And in fact, in this case, the mean absolute error was decreased by 10%. So estimating prices is one of the most popular statistics problems. However, some properties, even though they may have similar tangible assets, they may differ in contextual assets, like a neighborhood or just visual features of this particular property. Therefore, it had been decided to use visual features from satellite image to check whether those could improve the model. Data was split into training, validation, and test set, 90% for training set and 10% for validation and test set, and the test set was only used to do the predictions on for the results. Originally, the set consisted of 85 sales from New York City in 2015, and it had 30 attributes originally. However, some of them had too many missing data, or were copies of other columns, or due to plotting the correlation had been chosen to be uninformative. And finally, I only had chosen 9 categories to go forward to the model. For the categories that had been categorical, I had created dummy variables. Additionally, 57,000 properties were found to have 0 total square feet, total units, or price. Therefore, I decided to delete those because they may contain false information for the model. Additionally, 600 price outliers were detected by excluding rows deviating from mean by more than one standard deviation. And lastly, by plotting scatter plot of price and other categories, I have deleted 654 more players. And as it can be seen, correlation for 6 highest correlated categories had increased significantly. The satellite image data was provided by New York City, and it was taken in 2018, and it consisted of image of each building from the New York City geo sales dataset, and the property was in center, and it consisted of 500 feet radius of this building. So I've tested several regression models. However, due to checking other works on housing predictions, I've seen that LGBMR regression and retrogression had been really good. Therefore, I've chosen to use those. First technique uses random forest and gradient boosting. Random forests are typically really good with tabular data sets that has a lot of categorical data. Therefore, I've chosen to use this one. And the second model uses speech regularization and tenfold cross-validation to choose the lambda parameter. To extract visual features, I have used Insertion v2, tested on ImageNet, and only the first layer was used because I wanted to have the most general visual image features. After average pooling, only 32 features were extracted that could have been stored in the model. So to check the results, 2 metrics have been chosen, and it was mean absolute error and R-square. For both models, it had been shown that the visual features had increased the model, and the best model was LGBMR with mean absolute error of 300 to 2002K and R-square of 0.84, and it had been better with satellite images with 294K mean absolute error and 0.88 R-square. And in conclusion, in this particular model, it had been shown to increase the prediction using the visual features. However, more tests needs to be taken to prove this to be true.